Is it when the products can convert back to reactants?
Yeah, that's it. And do you know the factors that affect the chemical equilibrium?
I think it's the concentration,
Concentration, yes, that's one
the
of them.
temperature,
Sorry,
the temperature
yeah, the temperature as well.
and pressure.
Yeah, and pressure. But volume also indirectly affects the chemical equilibrium.
So can you repeat that? Sorry.
Volume indirectly affects the chemical equilibrium. Oh, it's saying my internet connection
Sorry,
is
I didn't hear
unstable.
you. I think it's like, yeah.
Um, Let me just close all these other things. Let me close this as well. So what I was saying is that volume, right? The volume indirectly affects the chemical equilibrium. Because volume is inversely proportional to the pressure, right?
Oh, yes.
Then that means like when the volume increases, the pressure is gonna decrease, and when the volume decreases, the pressure is gonna increase. So that's why I'm saying it's indirect. It's not like it doesn't directly affect it, but it's indirect. And in some situations, they might tell you that the volume increases. So you have to know that you have to relate the volume to the pressure. You know, do you understand that part?
Yes, sir.
Okay. Let's just go through this. So at the equilibrium point, that let's say at equilibrium conditions, the products are being converted to reactants, and the reactants are being converted to the product at the same time, simultaneously, at the same rate. So you understand that part?
Yes, sir.
Okay. Let me just open a question paper, because I think with the question paper it's gonna be easier for me to explain. I hope you don't mind. I hope you don't mind this.
It's okay, sir.
But from the chemical equilibrium, what have they taught you so far about it?
Um, just the Kc value.
The Kc value. K.
Yes.
So you know the formula for the Kc value.
Is it products over reactant?
Yeah, like it is product over reactants, but which property of the products over which property of the reactants? You know, because just
I
say
think it's. Is it solid and liquid?
no, I don't think you understand, because if I remember, like just from memory, I think Kc is gonna be equal to product, and this is gonna be like a small p here to represent the coefficient. And let me just change the color. I'm gonna write in white. reactants with a small r here. I think that's the equation, right?
Yes, sir.
So from this equation, you must recognize that these brackets, right, the square brackets, they represent the concentration. So Kc is not only like products over reactants, it's the concentration of the products over the concentration of the reactants. You understand that part?
Yes, sir.
Okay, let me just try to like scroll down here. I'm just gonna leave this formula on my screen. Question in paper 2 English. So let me just download this real fast. Sorry, but I think like my internet connection is not that good right now. So it's gonna be a bit more slower. I hope it doesn't inconvenience you.
No, sir, it's fine.
Okay. So let me just do this. Chemical equilibrium. Volume over time. This is the rate of reaction. Yeah. Question 6. So let's just do this. They say the dissociation of iodine molecule to iodine atoms is reversible. Is a reversible reaction that takes place in a sealed container at 727 degrees Celsius. And here we have the balanced equation, and they gave us the Kc. So then they're gonna ask for the meaning of a reversible reaction. Like when they say a reaction is reversible, that just means that, as you can see from here, the products can be converted back into the reactants, and the reactant, like that's basically it. A reaction is reversible when the products can be converted back into the reactants. I think that's simple enough. Then they say at equilibrium, the pressure of the system is increased by decreasing the volume of the container, but the temperature is kept constant. Okay, so we know that pressure is increased, but the volume is kept constant. So they asked us for how will each of the following be affected. So we're gonna say increase, decrease, or remains the same. Then the equilibrium constant. Does pressure affect the equilibrium constant?
So, what is the equilibrium constant?
The equilibrium constant, that's basically Kc.
Oh,
So from what you know, does pressure affect the equilibrium constant?
I don't think so. What pressure is, but
Sorry?
if it's the concentration remains the same, the temperature remains the same.
Yeah, because if a temperature is the one that changes the value of Kc, pressure just affects the equilibrium, the chemical equilibrium, but it doesn't affect the equilibrium constant. You understand that part?
Yes, sir.
Okay, then they say the number of iodine molecules. So since the pressure is increased, then we're gonna look at the side with more moles, right? Yeah, we're gonna look at the side with more moles. So we're just gonna look at this. This is 2, and this is gonna be 1. So you look at the ratio, right? Then you you decide if pressure is increased, it's gonna go to the side with less. So that means that this is gonna increase. That means that the iodine atoms are gonna be converted back into iodine molecules because because of the ratio, basically the ratio, because of this and this. Does that make sense?
Yes, sir.
So when pressure is gonna be decreased, this is gonna be converted to that. But since it's increasing, this is gonna be converted to this. Then they say explain it using Le Chatelier's principle. Have I taught you guys about Le Chatelier's principle?
I don't think so.
Okay, so let me just maybe like get a quick definition of Le Chatelier's Le Chatelier. Then they say this is a principle in chemistry used to predict the effects of change in conditions of the chemical equilibrium. So basically, using Le Chatelier's principle, you just explain what happens when the pressure increases. Like how I explained to you that when the pressure increases, you're gonna go to the side with less moles. That means the iodine molecules are gonna increase and the iodine atoms are gonna decrease. Like basically how I explained you heard how I explained 6.2.2, right?
Yes, sir.
That's basically how you use Le Chatelier's principle. You just tell them that when the pressure is increased, the products are converted to reactants because the products have more moles than the reactants, something like that. So you're gonna say
So does the concentration increase?
the concentration. Anyway, yeah. But I don't think the concentration is gonna increase because the Kc doesn't change when pressure. But you're right, the concentration is gonna change because more of the iodine molecule is gonna be formed. So it's going to be more concentrated than the iodine atoms. I don't know if that makes sense.
It does, sir.
Okay. Then with Le Chatelet's principle, let me just try to explain it more scientifically. So you're gonna say that when pressure is increased, because this is 2 marks, you have to state like 2 or 3 statements. When the pressure is increased, the equilibrium is gonna favor the reactant because it's the side with less moles. I think that's a more scientific way to put it. Then they say at 227 degrees Celsius, the value of Kc of the reaction is 5 times 10 to the power negative 12. Is the forward reaction endothermic or exothermic? Fully explain the answer. Then now we're gonna look at this and see that Kc has decreased, right? When the temperature decreased, the equilibrium constant also decreased. So
Sorry, sir.
sorry. Sorry, you can speak.
Sorry, sir. Ask you to repeat it, please.
Question 6.4.
Yes, sir.
They say when the temperature decreases to 227 degrees Celsius, the Kc is gonna go to 5.6 times 10 to the power negative 12 degrees. Okay. Then now they want to know whether the reaction is exothermic or endothermic, right? Just only like the forward reaction, not the reverse reaction. So from this, we know that temperature has decreased. Kc is directly proportional to the temperature in this case. How do I think we have to relate this to energy in order for us to get the answer. But let me just go through this. Maybe like the memo can explain it better because I don't know how to give it to you. So let me just open this on one side, put it there, and close this. I'm sorry. It's question 6, right?
Yes.
So at question 6, they say the reaction is endothermic because the constant decreases with temperature. and thus the concentration of reactants increases. So yeah, like since temperature is gonna increase, right? Let me just refer back to this formula. So now we're gonna use this formula again. This one on the side, right? Let me just do this so that maybe you can see it better. Let's do it in. So from this formula on the side, right, we know that Kc is products, concentration of products divided by concentration of reactants, right?
Yes, sir.
So when the temperature is gonna go up, when temperature is up, right, we can see that Kc is higher than when temperature is lower. And Kc is inversely proportional to the concentration of reactants. So when the temperature is gonna go down, where's that? I think this is leaching out now. Let me just go open this again. Use a black pencil. So they say when the temperature goes down, Kc goes down too. And since Kc is inversely proportional to the concentration of the reactants, that means as the concentration of the reactants goes up, the Kc is gonna go down. So you understand that part,
Yes, sir.
okay? So since Kc has been lowered, that means the concentration of the products has been lowered, but that of the reactants has gone up. So we know that lowering the temperature supports the forward reaction just from this equation right here. Do you understand that part?
Yes, sir.
Okay. So since lowering the temperature supports the forward reaction, it's gonna be endothermic. And can I get this off? Can I put this elsewhere? So as you can see, let me just rub these off. Just rub this off, all of that. So as you can see, the reverse reaction is gonna be favored because most of the atoms are gonna be converted into the molecules, right? Did you hear me?
Yes, sir.
So since the reverse reaction is going to be favored, right? That means the forward reaction needs energy in order for it to happen. And the reverse reaction releases energy in order for it to happen. Because temperature is directly proportional to energy. Does that make sense?
Yes, sir.
So that means in order for this reaction to happen, you have to add energy. So that means your enthalpy is going to be positive. And in order for the reverse reaction to happen, it's going to release energy. So your enthalpy is going to be negative. But I'm pretty sure at this point you guys did learn about enthalpy and energy changes, right?
Yes, sir.
Yeah, so like you should be familiar with enthalpy and all these other factors. So now this is the more tricky part. But how about we do this, because now as you can see there's this timer down here. So we have 9 minutes left. How about we solve 6.5 in a new session?
Okay, sir.
Yeah, so I'm just gonna end the meeting here and start another session.